So we're using a tool called Instruct for today's session. Since I'm an admin on this one, I'm just going to click play, and you should all see the same thing once you've filled out a first name, last name, and an email address. So why we're using Instruct today, what we want to do is we want to recreate Kubernetes first of all, and we want to put in a bunch of different tooling. There's no enterprise technology used in this lab, so nothing to sell here. This is purely just to show you how we can build Helm charts, how we can look for potential vulnerabilities in them using different tooling, likes of Trivy to understand for CVSS scoring with those CVEs. I put together another little tool myself just for comparing the EPSS, the exploitability scoring for, again, the contents of those charts. But we're going to use different tooling like Polaris, and we're going to use OPA Gatekeeper and things for basically checking for other misconfigurations in charts, but more importantly, being able to set certain guardrail controls inside Kubernetes to say, I don't want to allow this Helm chart to be misconfigured or talking to an endpoint that has, for instance, insecure charts. So again, there's a public, this is an old one, but CV 2022. So again, 2022 is the year. But this was an example where the user were actually able to, it's sort of a type of like cross-site request forgery, something on those lines. But again, it was for charts. So being able to say vulnerable patterns in the chart to be able to execute traversal. So again, we'll talk about a few examples of actual charts that are vulnerable in this session. I briefly touched on the thing about EPSS a while ago. Again, some charts are going to contain packages or containers that will have vulnerabilities that can't be necessarily be fixed. And then we make decisions on whether or not we use them. One of the technologies provided by First Foundation, open source, allows us to look at exploitability of a specific package or container, in this case, within our Helm chart to see how likely is that thing going to be exploited on a scale of 0 to 100%. And that allows us to make better, more informed decisions on whether or not it should be run in our environment. This is an output almost unreadable. We'll just look at it inside the view in a second. But again, we're at the point now where people can let me know if they're having issues getting into the lab. And if I'm not hearing any concerns at this point, I'm going to treat it as if we're all good and able to access the lab. We should be all good. So again, let me know if there's any issues in the chat. This is a pretty open-ended conversation, so if you want to unmute yourself at any point and just ask me to verify or, confirm also why I'm doing the things we're doing inside this lab, I'm more than happy to answer those questions. So just like that, if I give it another second or two in my environment, you should see this little start button in the bottom. So again, instruct means that you can now use the lab. So the first part I want to cover with this is because I don't know everyone on this session. Are they experts with Helm, or if they never used Helm before? Or do they have just kind of a general understanding of Kubernetes and Helm? But the first thing I want to cover is like this environment that we're using. Like if I say kubectl get nodes, you can see that it is a real Kubernetes cluster. I mean, I'm using a single node instance. I called my node Cloudsmith. It's been alive for 117 seconds, and of course it's K3s, so it's a lightweight cluster. If we say kubectl get pods, we do have some pods, or I should say dash A, but it's only a few generic pods that are running, most of them in kubesystem namespace. So what we're going to do is we're going to go through like the generic build process first of all to build a Docker container. I know this goes a level lower than Helm, but it kind of gives us a lot of the surrounding context because Helm is just a wrapper for different things that we want to deploy, generally speaking. So again, Docker container is the most common thing that we're going to deploy or create. So what I'm going to do is I'm downloading this little tool first called exploit check. I put this tool together the other day just because I thought there was a need for it. So what exploit check is doing is it's taking those other publicly accessible data streams, so things like Kev, the known exploits and vulnerabilities. I'm taking down a CSV for, again, CVEs and their associated CVSS scores. We're also taking one for EPSS, the exploitability thing I talked about a second ago. And what this will do is if you plug in exploit check and you query against a specific CVE out in the wild, it'll give you this little tiny report. And this report, what it's doing is it's looking at, say, a CVE. Generally speaking, we talk about the CVSS, the exploitability score. So again, on a scale of load critical or scale of 0 to 10 is the scoring system that creates these severities. But not always is there a severity for CVE. We'll come to those in a while, but generally speaking, these come from cases where security researchers say, look, we've got a description of what the vulnerability is. We just haven't agreed on a finalized score. With no score, it's very hard to build automation systems around what is or is not good in our environment. We just have an ID or a description of whatever that vulnerability is. But EPSS tells us how exploitable, how likely is that thing to be exploited. So in this case, this CVE was both a critical CVSS, but it's also a critical EPSS. But there will be cases where you're going to have, for instance, a high or critical CVSS, and it might be a relatively low EPSS. Or in this case, like I mentioned a while ago, there is quite literally no CVSS score signed. So where there's no CVSS score, it's very hard to build a detection system to say, okay, if I get this score above a certain threshold, I don't want to use in my environment. Without a score, what's the logic I'm going to use? So EPSS can be a kind of a last line of defense since it's not manually created by a security researcher. It is an ML-based system that's on a rolling basis. It's updated every day. So it's a likelihood each given day of this thing being exploited in the wild. Now I'm just setting up this environment, this little tool here just as a way to set up the scene for what we're going to look at later, which is sometimes in an environment you have to have acceptable risk, I guess is the best way of putting it. So, you might have, for instance, a high CVSS score with a low EPSS score or high EPSS relative. But in those scenarios, if there is a fix available, then great. We'll go into Trivy, we'll see it in a while, and we'll pick those fixes and we'll fix them, and I'll show you how to do that. But if there is no fix available for a component within our Helm chart, do we just go ahead and deploy anyway? Or do we make some kind of informed decisions on how we take action going forward? And that's kind of what this exploit check tool is going to help us do in a while. So again, any questions, feel free to ask them. But this is all we're going to do so far with this exploit check. There's little feature flags you can add, for instance, to get full output, to get more information about the KEV data or from the CVSS findings. But again, not really relevant to this demo right now. So the first thing we're going to do is I'm going to build a Docker container. So I'm using pip to download what I know is a malicious Python package, which is Langfo version 1.2.0. It's an AI type package. I'm pulling in no dependencies, and just like that, it successfully downloads. We make a local directory called AI containers. Honestly, we could call it whatever we wanted. And now that we're in that AI containers folder, I'm going to make my Docker file. For those who've never done this before, this is a very simple Docker file. What we're saying is run that package we said there a while ago. We're actually running the full command, which is pip install the Langflow 1.2.0 without any dependencies. I'm exposing it on port 8080, and it runs basic commands for this HTTP server on port 8080. So just like that, hit enter, and we have our Docker file. When you have a Docker file, this is basically the template for what it is that we're going to create. So if we said Docker build, now I've pre-installed Docker on this environment. So you say Docker build, and we're going to call it AI image. You could call it honestly anything, it doesn't really matter. But that's going to be the name of our container. So just like that, we give a few seconds, you can see where it's pulling the sources from and what it's installing and wrapping it all together. So just like that, we now have our AI image. You could, for instance, I'm going to turn it to, so Trivy supports a bunch of different file formats. So if I was to convert this into, for instance, a tarball, that's fine because Trivy will still be able to do image scanning even on that tarball. So tarball is just that encrypted file. So give it a few seconds and you get something like this. So, I mentioned there, I brought in a critical Python package. I don't want to go into this in too much length because we are focusing on Helm, but my point is this thing is going to go into a Helm chart. So this is a Langflow package. We know that it's got a critical vulnerability in version 1.2.0, which is the version we're on right now, but it's fixed in 1.3.0. Knowing this, we're like, okay, well, I could fix that. However, there are cases where, say, for instance, there's a high CVSS or CVE. We can go into the score in a second. It's certainly affected in this version, but there's no fixed version available. And without a fix, what do we do? So that's why I put together that little exploit check tool. So you could, for instance, take this CVE, I guess is the one we want to focus on. And I can make that a little smaller just so it's more readable. But if I was to take that CVE ID or CVE, yeah, CVE ID, so we'll take that and we just do the output, what we should see is you have a high CVE. And again, it's been around for a while now, since the 8th of 2025. However, the EPSS, the likelihood of exploitability, is really low. It's 0.01%. So I would say it's kind of like we can't fix it. There's no current fix available for that vulnerability. However, the likelihood of that thing being exploited in the wild is pretty low. So we could make certain decisions about, like I mentioned a while ago, acceptable risk, and that would be one of those examples. So we're going to use a multitude of different tooling. Here's an example of where we used Trivy as our common scanner for finding vulnerabilities and fixes where available, but just enriching it against other data sources to make better informed decisions. So, like I say, you can just use Docker image here, and you can see that your image was just created there 2 minutes ago. This was the one you just built there with the Docker file. If you want to inspect the image further, you can run commands like docker inspect, and that kind of gives you that full view of like the architecture and the operating system of that image that you just built. Like we knew it's going to be a Linux image, but things like those commands that we specified, like Python and have an HTTP server running on port 8080, all that information is kind of visible here when you inspect it. And naturally, the history will also show you the commands that are executed off the back of this. So things like run whatever command is inside that. But again, not really interesting, just that it verifies what we just created. So Cloudsmith, where I'm coming from, is an artifact management platform. So what the goal is at somewhere like Cloudsmith is similar to an Artifactory or an Nexus, is to push these artifacts, whether it be software packages, like a Python package we saw there, or the wrapped up Docker container, or even wrapped further in the Python, or sorry, the Helm chart, is being able to send those to a centralized artifact solution where you can say, okay, we don't just audit who created it and how old it is, but we can do things like setting open policy agent rules to say, well, don't let me use something that's known to be bad. So here's a perfect example. If we use the Cloudsmith CLI, we can list the packages, and we can see that that AI image, if we were to push it to Cloudsmith, which I had already done earlier, you can see it's quarantine. And by quarantine, it means it can't be used by an end user. So if we were to say, for instance, list this package that's now inside Cloudsmith, it's already safely there. You can see it was fully synchronized, was sent up. It's the AI image. We can see when it was sent. There was a security scan done. So again, this was all automated, the Trivy scan on Cloudsmith's side, but we know it was quarantined by a policy. So you know you can't use that thing. So since it's OPA, and again, we'll use OPA Gatekeeper in a while, which also has this decision log logic. But decision log is a way to see all of the associated data for that decision. So when we say, okay, a policy, we're going to use OPA as our policy decision making engine to say, don't let me use containers inside Helm charts where the known vulnerability or CVSS or EPSS goes above a certain threshold. So that's great. You know, we have that, and decision log lets us know how that decision came to be. So we know the action that was taken was it was quarantined. It's because well, we're ignoring this CVE, but we know it found this CVE where there was that high or critical vulnerability. So we can see some high vulnerabilities. There's definitely a critical vulnerability in here as well. But all these different NVD findings, you can look at not just the the CVSS version 3 score, which is the like whatever out of 10, but you can also look at the percentile of the EPSS, which is the likelihood of that thing being exploited. We already have a policy that this was the policy we used to create it. So actually it's better to read this in Vim. But basically what I'm saying is with the Cloudsmith OPA, we were saying if the CVSS score goes above 7, and more importantly, it had a fix availability, then of course now you can quarantine it and take action on it. Reason why I quarantine it where it has a CVSS score above 7, but where also fix available is, I don't want to quarantine every single dependency if they're above a threshold because I don't have enough context around it. And more importantly, even if I do quarantine it, if I can't fix that vulnerability, it's kind of just slowing down process. So I want to look at things like where fix available, where it's above a certain threshold, and in decision log, being able to look at like what is the likelihood of that thing being exploited really helps me make real decisions about, okay, am I going to allow this thing to actually exist in my inside my Helm chart? So just like that, if I wanted to wrap this up in a Helm chart, or in this case as a Docker deployment, or yeah, sorry, as a Kubernetes deployment manifest, I could just create the deployment. All I would do is then point to docker.cloudsmith.io, which is the registries where we're hosting that image that is currently quarantined. It will say that it's deployed, but naturally, when you actually check the state of those pods, they'll be throwing errors. Um, sorry, I'm just going to say kubectl get pods. So you'll see that they get errors, the image pullback off, and the reason they're getting full pullback off, as you can guess, is that Cloudsmith is returning saying, we are forbidden. We're not allowing you to pull that image. So again, it's quarantined, it's isolated, it's inaccessible inside Kubernetes. So we want to do something similar, whether you match this together yourself with OPA Gatekeeper, Trivy, these other tooling, or whether you use Cloudsmith as your centralized registry, it shouldn't matter. We're just showing you how to apply this logic to kind of secure Helm charts. So just like that, we know that this thing is deployable. Great, we deployed it and it threw those image pullback off errors. So to delete it, it's just a case of running that same command, but it's basically kubectl delete of the same thing. And just like that, if we say kubectl get pods, they're gone. So that takes us past the first stage of this workshop. Now, what we're going to do in the next step is we're going to really look at it more from the helm of lens, or the lens of Helm itself. So, for those who already probably know this, it's like you can talk to a centralized repository like we saw there. You can push your manifest to the repo and then pull those down wherever that repo is. Some people have Helm charts in Bitnami. There's loads of public examples all over the place, or you can have it in something like Cloudsmith. And developers end up using those charts. So it's important that we secure them at the earliest possible point. So to see what version of Helm we're using, we can run Helm version, and you can see I'm using what should be the latest version, 3.19. So that's great. So if we use Helm list, this will list what is the current Helm charts we've used in our environment. There should already be a default one there called ingress nginx, just for the purpose of understanding. kubectl get pods will show us that the pod was deployed to the default network namespace from that Helm chart. So again, it's that my ingress nginx controller. If we look into it a bit further, let's say check the labels associated with the pod, or check the information. Let's say what did I want to do is just get it. Oh yeah, everything in output in YAML. You can see like how that thing was configured. But rather than just reading one big ugly configuration for that deployment, I'd rather go individually through those insecure configurations. So the first one is things like host ports. Now you could run this command in any deployment, honestly, of Helm to check for things like, is host port available or configured? In this case, I believe there's actually nothing configured here. We have null values on host port. So that's great, but like, why is this risky? Well, if you did have host port configured on this default example that we just saw here, it potentially exposed the port actually on the node's network interface. So there'll always be, and we'll see this in Polaris in a second, there's always ways to configure kind of least permissive things, whether it be, okay, I want to give certain permissions to do something. Well, we can do that in our we'll see that in a second again, is like the permissions that we allocate on it. But in the case of even network access, we don't need to make these broad decisions on just allowing whatever we want on it. So for instance, here, the network admin capability, you can see that it's set to net bind service. I think that's a good thing. So, or sorry, yeah, no, that's a good thing. So this is least permissive. If we had, for instance, net admin set within those capabilities, that would allow manipulation of network interface, routing rules, all of this kind of stuff. So netadmin is probably, yeah, no, netadmin is okay. Net bind service capabilities ensures that all processes are running inside the container. Yeah, that's better. So we want to obviously run it within the container and have no ability for us to, for instance, move outside of the capabilities of that actual container itself. So these are seem kind of obvious things to check, but again, it's good, important to have this context of like, okay, our resource constraints configured. Yes, we have explicit limits on resources configured as well on this. If there was no limits set, of course, that could be exploited for all sorts of nefarious conditions like crypto mining. You can also check, for instance, was the default service account It's always important where possible is to define actual scoped users and permissions associated with them. Default is generally speaking never a good practice to apply across the board. So these are simple checks that we can apply, things like quality of service as well on our pod. And we'll go through actually ways to check for this as well on the actual upstream Helm projects via like GitHub search to actually check where these misconfigurations might exist on projects. So this part is pretty straightforward, but this is just looking at an existing Helm thing that's deployed, and we're just looking for is it secure or not with some basic simple checks. We actually did a session before platform engineering before on is your Helm chart a security risk. It was more of a presentation style, so again, that link is also provided back there. So we're going to cover some of this topic content that was already on that session we mentioned before. So it's using Helm to create a default sample chart. Now, what's really cool is that you can even run a command to create sample charts, skeleton charts. So in this case, we're going to show how even the skeleton chart could still have vulnerabilities in it. So I'm going to package my chart, and you can see here, it successfully packaged it, and it's now running in root, and it's my sample chart with a version TJZ file. So if I was to unzip that TJZ file, you can see the content that's in it. So it is a skeleton, as I say. You have a chart, you got the values file, you've got services counts, you've got services, ingress, all those things are already there by default. So what I'm going to do is, did we already run this? Oh yeah, you can read the content of the chart. So like what is this chart? So like it's got a name, a description, and a version. We haven't specified versioning, so it's always going to be that generic 0.1.0, and it's just called my sample chart with a description saying it's a Helm chart for Kubernetes. There's nothing special about this. So if we were to show everything, because that's a thing you can do, you can just read the whole content. Helm is just essentially a wrapper of all these different YAML manifests. So it's just one big YAML file. And again, by default, you can see certain things are commented out where it would be essentially recommendations about better configurations that you can do. And we'll cover that in a second. So what I'm going to do is I'm going to template that TJC file. Once we've templated it, I'm just going to take that template and turn it into a simple YAML file. We mentioned there, it's just wrap it all together into one YAML file. And the reason I do that is whether or not you decide to deploy via Helm or you want to do it via kubectl, you could run kubectl apply-f on that YAML file and boom, you've deployed all of the things that were wrapped together in that template. Now, the template's not interesting. There's no container image that we referenced there a while ago that we're building. It's just the actual skeleton. But if I were to check what got deployed, you can see, yes, it was deployed via Helm. You can see it's managed by Helm when we look at the labels associated with that pod. If we check the logs, that will tell us if everything was okay. And sure enough, we see there is actually an issue. It's in the test connection piece. It says there was a connection refused. Now, we could remove this altogether to get rid of that simple little error. Or what we can do is just check to see if there are real vulnerabilities. As I mentioned, there should be about three kind of higher critical vulnerabilities already in this default template. As I say, it's just default template. So, this is what everyone would build when they start deciding what they actually want to deploy via Helm. So you can see there are some that are low, some that are medium, some that are high. You can run the same command to just filter for severity high and critical, and then you get rid of all the low value and medium stuff. So as I mentioned, there's three failures according to Trivy. So these are three things that we should really take action on. When you look at them, they're not real vulnerabilities. They're more like misconfigurations. And even then, you need to look at it on a per case basis about whether or not you take action. For instance, they're all about security context. So you can see security context, security context. And what security context is all about is, if I say privilege set to true, well, you're giving them full privileges, admin privileges to do whatever they want if someone were to hijack that workload. So what we want to say is if someone were to, whether it be for an engineer who actually should have access to those containers and they terminal shell in a container, then you might want to give them read-only root file system. So they can only read only on the root file system as opposed to having write access on that root file system. So let's say we have our template. So let's fix the misconfigurations. A simple example here is I'll download basically the same file. So, say first we just want to check the file that we want to change, which is the test connection.yaml. Reading the test connection YAML, you can see that under oh yeah, so this is the problem. The default doesn't even specify what we were talking about there a while ago, security context, because it's not focused on security context. By default, it's given more access than it actually needs. So what we're going to do is we're going to delete that file I just mentioned there, which is this one here, that doesn't mention the security context. Then we're going to download one that I built earlier on GitHub. And when we look at the GitHub example that I just downloaded, we can now see that it looks kind of like the other one, but you can see now it has a security context section which says, run as root set to true, non-root. So you don't have root permissions. The allow privilege escalation is false, so you've prevented them from escalating permissions. And the thing it was flagging about earlier, which was the read-only file system, is set to true. You are configuring it explicitly to say it's read-only root file system. So in that scenario, if we were to wrap up our chart again, we haven't done anything interesting with Helm yet. We just said, okay, I'll rewrap a file that I had earlier. We can, let's say, convert this. So we know that we have the file already there. So let's say if I want to templatize, I guess the right word, turn it into a template, we now have that big YAML file we talked about earlier so that we can convert it into a file called less vulnerabilities.yaml. And if I were to delete the existing deployment, which was the 4 pods that were created from the slightly less secure version, and I apply the new one, what you'll notice is the pods should all have successfully been they're running, so there's no issue there. But if we were to run the Trivy scanner, what we'll notice earlier when we had 3 critical vulnerabilities, we should only have 2 now, which you see there's 2 critical vulnerabilities. So I know it seems trivial, but these are the kind of things that you're expected to do. Like a lot of these Helm charts, honestly, the majority are not designed with least permissive, controls in place. The expectation with Helm is that yes, these charts exist, you can download them and use them, but you are still expected to scan them for misconfigurations or excessive permissions and exposure, and then you're expected to make those changes yourself. And again, this is a very simple workflow for it. There's optional hardening you can do, which is going into those examples. Like we saw here, this is yet another identical scenario where it should also have read-only root file system. And you can, of course, do something like that where you say in security context, set that to true. You can also go further than what's specified in Trivy and look at other capabilities that do or don't need to exist. The other example, I believe, was around the binding on ports. And you can also address that by specifically going port 8080, for instance. So there's different things you can configure here. But that should give you a simple use here of building your own chart from a template and then scanning it with Trivy. We're just moving quickly through the lab because I don't want to fall behind on time, but at the same time, always happy to hear questions if there are any. I've documented these kind of workflows before in other blogs. So I had a piece I wrote for All Things Open on the topic of detecting vulnerabilities in public charts. I also wrote a piece, I believe, with platform engineering, and correct me if I'm wrong, Sam. But the idea is being able to actually go home and check, okay, here's the workflow for checking for misconfigurations. So this should be a little bit of a fun exercise. What I'm going to do is I'm going to take us out of the terminal for a second. If everyone has access to GitHub, you can just copy these queries, go into GitHub, for instance, and in this, so if you'll see here, github.com/search, which is this tool here. If I was to remove this, you can see GitHub search is where you can search things in GitHub, which honestly, I hadn't really been using this properly in the past. So let's say I run a query and I say, look for templates where RBAC YAML has API groups and resources and verbs and all that set to asterisk. And asterisk is wildcards. That's just allowing everything. And we're saying it's Helm. So these are perfect examples of literally you can look at all the paths and they're all charts and Helm charts. So it's all Helm. And there are dozens and dozens. In fact, here are 308 different projects code snippets where this resource is set to wildcard. Now you have to ask yourself, do I need to set wildcard on all resource and verbs? When I'm talking about verbs, we're talking create, read, update, delete. So do you need to give those kind of access controls always? And again, resources, like to which resource do you want to allow create, read, update, delete? If you're saying wildcard on do whatever you want, and then by the way, set asterisks on any resource, API resource, like for instance, secrets, config maps, or services, I don't know if that's necessarily a secure thing to do. And finding these kind of examples in projects like Zalando, for instance, these being kind of enterprise organizations providing their templates, I don't know, it's something worth reviewing and check and see if this also exists in your Helm charts. So if we just go quickly back into here, that's just checking for insecure RBAC, the role-based access controls. But there's examples here for security context. I'm sure we'll see a lot more examples here. So this is the thing we talked about a while ago, which is it's one thing when we ran the Trivy scan and it showed you could have prevented it by giving less privileges, but one thing you definitely don't do is explicitly provide privilege set to true unless there's a good reason for doing this. Because what you're saying in security context, saying, okay, this can't be misunderstood. I'm giving you whatever you want, full privileges to do whatever you want once you're in that Docker container. And that just seems a bit strange. Like some applications need it. If you were a Falco security tool and you need to monitor system calls from the kernel, then yeah, it makes total sense why it may need to run in privileged mode to achieve that. But a lot of applications, when you look at some of these container demos, they don't need to run as full admin level privileges. So to configure explicitly security context privilege set to true in 171,000 instances, it just seems a little unlikely. Like something like Cilium, it makes sense. It's the CNI for Kubernetes, the container networking interface. So that would make sense, but other projects don't. So if we go back into our lab, we could look at default values exposing secrets. I always find this a funny one, and it's a very simple query to run in GitHub search, but something on the lines of, okay, check within the charts directory, check to see for anything that says password base64 Helm. You get where I'm going with this. So what we're trying to see here is there are going to be cases where someone's configured secrets, which are the sensitive credentials for your um, Helm chart or anything in Kubernetes for that matter. And they've got some sort of basic authentication set by default. But what they're doing from a security perspective is they're like encoding it in base64. So what I'm doing is filtering for those base64 instances. So why I find that a bit silly is, let's say if we went back into our environment, as I mentioned, it is good practice to use secrets, definitely better than hard coding sensitive credentials, which there are examples, and I don't want to go over those, of projects that are just putting plain text passwords in, which is really sad. But also encoding isn't a solution either. Because let's say if I were to echo that base64 token, whatever it is, output, and then I want to decode it, then you can see, oh, look, that's my secret password 123. It's not it's super trivial, is what I'm saying about decoding it. So yeah, if someone doesn't want to be seen to providing plain text passwords or secrets in these projects, then yeah, they might want to encode it, but it's super easy to decode as well. So this is also something worth doing, is just looking at also these projects and better understanding how are they actually configuring sensitive credentials? Is there a proper way of following this process? Again, why am I showing all these examples of misconfigurations? Well, Microsoft Defender for Cloud, and I'm just going to share this link because it's something that came out this year, and hopefully my internet connection. Okay, perfect. They wrote a piece, and it was from their security researchers, and it was about the risk of default configurations. What their argument was is that there are too many Helm charts that are just accessible and not just random projects. I'm talking enterprise technology where these default credentials are just asking to be abused. And perfect examples being like Pino, which is a project here. They give you a quick start. And on the quick start, it's like they'll even say, look, this example is purely as a purpose of reference for deployment. It's actually your responsibility to configure the permissions and controls. Some of them go a bit worse in the sense of they actually are misconfiguring it. For instance, they might set we talked about earlier, things like no port configurations. You can see here, look, that same thing we talked about earlier, where you run that query on GitHub search, they were able to just search for, show me all the templates where someone's configured a load balancer, essentially publicly exposing it and making it accessible to the public internet. And actually, Selenium Grid, amongst many other projects, showed up as having these misconfigurations. So if we were to like leave this page, you would actually be able to do exactly this yourself. You can look for, show me anything where ingress is set to type load balancer or type node port, but they've gone a bit further and they've filtered it specifically for the Selenium Hub project. And you can see to this day, there are still 127 instances for exactly that project. Now, again, a lot of these aren't these are just random people. You know, you can see people have forked the project and made their own versions of it. And also, as they said here, as guidance, have gone and just used the default example and kept it that way because they're still configured for load balancer type. But when you actually find the Selenium project itself or any of these industry projects still doing that, I think Meshery still had the misconfiguration. So, you know, it's just one of those things you want to check for to see, look, just because a vendor provided me a template doesn't mean they provided it being the most secure thing. They just provide as a way for me to get up and running quick, and then it's up for me to actually do the hard work. So yeah, look, I've got an example here for the meshery. So if we were to go up to that search view, filter, at least this worked the other day, it should probably still work. Exactly. Look, you can see here, I'm also filtering for load balancer and node port. And you can see this load balancer configuration here on port 9081 is on the official Meshery project, meaning people who still use Meshery and are using that default deployment are exposing it on port 9081, which is pretty concerning when you look at it. But again, I would disregard these other projects where people are like quite literally just doing their own thing, which is nothing to do with the official project. So yeah, I hope that part was pretty interesting. Um, so next we'll quickly move on to a tool called Polaris. Polaris is a really great tool, though it takes sometimes a little bit of time to deploy. Actually, that was pretty quick. So I've deployed Polaris. It's from Fairwinds. I don't know how many people are familiar with Fairwinds, but that's okay. So what I'm doing is I'm changing directory into this Meshery directory just to prove, well, okay, if I pull down everything from Meshery, which was a project that had the misconfigured load balancer, let's see if it's still the case today. So Helm template meshery, I've put it into this rendered file. As I mentioned earlier, you can convert the whole Helm chart into a single YAML if you want. I'm just going to change directory and then run Polaris audit on that rendered file. Now, unlike what we saw with the Trivy scan earlier, that was more focused on, okay, are there things that are misconfigured that I can focus on, or are there explicit vulnerabilities that have fixes available? This actually just kind of looks at all of the potential misconfigured things that you should kind of look at, which is kind of a nice complementary tool. So they do it on a scale of, you know, real danger to your environment against things like, oh, it's kind of warning, but like there's probably a reason why that maybe is configured that way. So things like CPU limits, you know, there might be reasons that you don't want to set it, but it's good practice if you can. It's more efficient to configure actual limits. Every time you make these changes, you can run this Polaris tool to again check where you are on that kind of traffic light system. So let's say if we focused on the danger ones. So there was things here, I think, on the topic of allow privilege escalation. We talked about it earlier that did show up in the Trivy scan. So you'd want to configure privilege escalation set to false, where it's going to run as not run as root allowed. You want to, of course, say, well, we want to allow it to run as non-root as opposed to having root access. But when you do that, you want to go a level further and then say, well, I'm going to give it a specific UID. User ID is like the level of permissions that I do want to grant to that specific run user. So yeah, we have that rendered file. As I say, it's just a massive YAML file of everything that comes from that meshery chart. So you can check for instance, we talked about earlier, things like you wouldn't want to give all the verbs all the access. You can see here that rules are set, any API group, any resource, all the verb access. Yeah, there's pretty much the only thing that they've set any limit on was the get verb for these non-resource URLs, which are metrics, health, and ping. But generally speaking, everything has clear access wherever they want. The load balancer piece should still be there. So if we said grep load balancer, um, balancer, load balancer, did I spell that right? Balancer. Okay, I did. I don't know. Maybe it's not configured with load balancer anymore. Um, Where's the network section on that deployment? So, oh yeah, look, it is. So of type load balancer, maybe I just needed to do proper uppercase, lowercase. I don't know if that was a thing. So if I say grep, oh yeah, it is. So you get my point. So between Microsoft disclosing that the project by default exposes the application in a non-suboptimal security perspective, like it's publicly exposable. They haven't actually made any changes. That Helm chart is still the same way as it always was. So again, something worth flagging. There are unvalidated empty environment variables. Okay, so that's something I missed out. There was a CVE that I mentioned briefly at the beginning of the session, and it was something found in like 2022. And the reason it was weird was because users were able to perform like there wasn't validation performed on certain fields, and they were able to do that to move laterally. So this is the same, you've got this Meshry server callback URL, but there's no specific values or configuration set on it. So these are unset, and again, it can lead to undefined or insecure behavior at runtime. So what we're saying is when you've actually got around to deploying it, you still want to, no different to a legacy application we would have built 20 years ago, you want to also stop people from forming kind of vague actions on unvalidated fields. You think of like SQL injection, that kind of stuff. It's no different with Helm charts. So again, if there's no reason to be uh, having this, you could actually either just explicitly remove it, and that way you avoid the issue of unvalidated fields actually being exploited. No volumes and secret management. Again, these are just things that like they can't know how you're doing secret management. So I guess they just leave the chart the way it is, and it's up to you to set the relevant controls around secure secret injection or prevent secret injection. So we'll move on quickly because I know we've got about 14, 13 minutes left on the session, and we've got about two more parts on this. And I also want to make sure that people are answering questions as well. So yeah, if you've used OPA Gatekeeper before, then you know exactly what we're going to do. OPA Gatekeeper is more focused on the runtime aspect at Kubernetes layer, but there's a whole bunch of different layers that you can use OPA at. So the first thing, as I mentioned, is we have Cloudsmith CLI, and we can list the Docker containers. As we mentioned earlier, we had a quarantined container, which means we knew we couldn't use it. If we use Trivy again one last time, we can scan the safer AI image, which is basically the same AI image that I built, but this time I patched, like I'm using on version 1.3.0, which addressed most of the vulnerabilities. But what we noticed is some things like can never be fixed. There's no fixes available. So we can, of course, create reports for leadership and JSON outputs and say, look, here's the thing that we've got, and here's all the references and CVSS and NVD data, and that's all great. But I actually want to make sure that we're not using insecure things in our environment. So OPA Gatekeeper could be used as one example, and I wish I used this example for this lab, which is to stop you running something with privilege set to true, or prevent me from using load balancer if I don't need to use it, for instance, on a Helm chart. Those kind of examples could be really good use for OPA Gatekeeper. I'm going to do a somewhat simpler example, which is just locking down to only use images that came from Cloudsmith, because we mentioned earlier Cloudsmith was doing the scanning for us and it did the enforcement to make sure we are only using the secure thing. So I'd rather make sure that all going forward, our Helm charts are only referencing images, Docker containers that are coming from Cloudsmith registry. So the first thing you do is you just run a kubectl apply, and it creates all this CRDs, the custom resource definitions, essentially the APIs for Gatekeeper. If we run the get pods, it should just take a short while, and you can see all our pods are running for Gatekeeper. It's super simple. So with Gatekeeper, there's this logic of constraint templates and constraints. I know the names aren't exactly useful for remembering. So you can see here that I downloaded a template I built earlier, and I applied it. If you want to read what is in that constraint template, this is what we're doing. It's a little bit ugly, it's Rego, but it's super easy once you get used to it. What I'm saying in it, because it's so flexible. So we're saying we're creating this resource called Kubernetes allowed repos. In the specification, we're saying this is going to lock down to the CRD spec for these targets. So I'm saying admission K8 scapekeeper.sh is the target. And then we're saying, okay, containers, the violation will be if containers do not start with container image with the string docker cloudsmith.io. So that's where our images are stored at. And that means anytime you want to have an image, it needs to have that string. And then again, the output message, aside from enforcing it, the message will be, it's not from an allowed Cloudsmith repository. So that's great. That's our, we already created it, so it exists. The second thing you want to do is create the constraint. And again, I'll show you what the constraint looks like now. So we just created that, and the constraint looks like this, where we're saying, what are the things we're scoping it to? So we're matching the kinds. We mentioned there, you can lock it down to pods, it could be services, deployment, stateful sets, all these different things. And then you can lock it to the API group that those kinds exist in. So I'm kind of setting it to just about everything. Well, actually, I said pod, but we could configure services, whatever it be, to also say they're also only going to use the Cloudsmith upstream registry. So we've also enforced that. So now our OPA controls exist. If I were to pull down a random Nginx deployment manifest, again, built it earlier, and we try applying it instantly in milliseconds, you can see, look, it's forbidden. We cannot allow you to deploy that, whether it's from Helm, whether it's from a random YAML file, whatever way you're trying to deploy that thing. The validation, the admission webhook is going to prevent it, and it's denied because we're only allowing Cloudsmith images to be used inside our environments. And then you get that message saying it's basically not from the Cloudsmith repository. You're pulling it from Bitnami or somewhere else, which we, of course, don't want you doing. So that's a really cool use case for OPA Gatekeeper. But like, just to prove that this is the case, you've probably all heard of the Bitnami incident by now, which is, Bitnami was a great source for all your images, especially Helm charts. You got all your stuff there. And then VMware, which is now Broadcom, they just kind of discontinued service. So, you were relying on those charts and now they're not accessible. So let's say if I wanted to add the charts from Bitnami, which by the way, Bitnami still exists. It's just, I believe it's all just like latest tags, which is pretty frustrating at this point. So happy helming, we've pulled down our Bitnami charts. If I wanted to pull, for instance, the latest Redis one, you can do that. But like, again, if I tried installing it, that's where my admission webhook is being enforced. It's not going to allow that. See the way it says validation gatekeeper denied the request. So Helm's allowing me to pull charts from random upstream locations, but I'm not allowed to actually use them. The admission controller is always going to prevent me from doing that. And that's what we're doing with OPA in Cloudsmith, is saying if something has high CVSS, high PSS, these kind of things on the artifact level, we'll never let it go into Kubernetes. And likewise, in Kubernetes, we're using OPA Gatekeeper, say, I don't want Helm charts to fall outside of these practices. I could have a whole other session on just OPA Gatekeeper because honestly, it is a really cool technology. So a perfect example here is like, let's say I try to run a kubectl from random Bitnami image, again, forbidden. If I try to do the same thing, but this time I'm going to point to, docker.cloudsmith.io for the AI image that is already quarantined, nothing's going to happen because it's quarantined, because it's got the malicious packages in it. So it's the bad image. However, we're not getting the admission webhook preventing us from doing it because we're forcing developers only to use the approved secure upstream. But either way, that specific image is actually banned as quarantined right now. So developers forced to only use the good images. And that should take us to the last section. I know we've only got like 7 minutes, so sorry, I'm going to have to rush this, but it's going to be on the topic of software provenance. I really should have built this around Sigstore, since keyless signing is what everyone's talking about now. And this actually around PGP. But let's say I build a new chart, it's called my chart. I can use GPG, sorry, and I can check the version. So great, I've got GPG already installed. You can generate a key. The process here is we're going to say, let's use the default RSA. What's the key size we're going to use? We'll say it's 4096. How long does it live for? Well, it can live forever. So I'm going to say does not expire, 0. Is this correct? Sure. I'm going to say yes. I'm going to put a real name. For the purpose of this, just so we're all in agreement, we're going to call ourselves George Clooney. George Clooney is our key owner. The address I'm going to put in is my email address. So it's now ndouglas at cloudsmith.io if anyone needs to contact me. The comment we're going to put in here, which is demonstration for software provenance in Helm. And then yeah, it's like, okay, do you want to change the name? And thing, I'm okay, right? So I'll say, oh, we're okay with it. Then they'll ask you to put in a passphrase. I just put my whole name, so like Nigel Douglas. And the reason I'm doing that, they'll say, well, that's pretty insecure. You need to put a digit or capital letter or something. I'm fine with it. So going forward to interact with that Helm chart that's going to be signed, I need to essentially log in with that password, if that makes sense. So you can see it signed off as George Clooney. Again, the message was demonstration software provenance. It's nothing interesting about this. You can list the keys that are available. We should only have the one, which is the one we just saw there a second ago that we created. You can export these so they're accessible. Again, if you're going to use them, you will need to be able to sign in. So I think I did that correctly. So that's perfect. So when you're doing the package process with Helm, what you can do then is sign as George Clooney with the message. And as long as the keyring exists, then as long as I say Nigel Douglas, it should be like you successfully packaged that chart. The ID is only the approved author should be able to make the changes with that key. Do you know what I mean? So if I try doing it as, I don't know, Leonardo DiCaprio, like it shouldn't work in that scenario. So what we're going to do is you can verify the authenticity of your chart. So you can see this Helm chart, again, was signed off by George Clooney. Here's the fingerprint to prove it. All this stuff is actually done for you within Cloudsmith. We don't have obviously any time with 4 minutes left to show you how this works with Cloudsmith, but essentially the provenance, the author who created it, we create the SBOM, we create the software profile, so to show the author and who created it, and that's important when we're building and using charts. You want to know who actually created these things, and like, who's the original author, because like anything random from the internet, we don't know if it's packed with vulnerabilities or worse malware. So let's say I want to when it yeah, so when a provenance was set up on it, you should have that local profile, and the profile looks like this. It tells you what the application is, the version of it, and more importantly, like who's the person that authored it. So if we were to install, it would be something like this, like Helm install with the generated name, and then of course it still won't work. It should work, but it's actually not working, not because of any issue with the PGP, but actually because we're only allowing it from Cloudsmith images, the previous OPA Gatekeeper policy that we created earlier. So that ends the workshop just in time. Look, I know there's so much more I'd love to cover in these workshops. What I would say is if you do want to play around with the lab longer, you're more than welcome to. If you have questions about the content that's covered, we're more than happy to answer it. And I'm just going to ask it now if there's any questions that I could be helpful enough to answer.
And I think I'm fine to stay a little bit over if others are as well. I think this was a lot of information for people to digest. So maybe I would say a first place to start, Nigel, you mentioned a few things throughout, but what are some things people can do next right after this?
Yeah, I think there's a few things. So one of them is that tool, the exploit checker. I only put this together recently, but I'd love for users to actually just try that out and see, do you have CVs in your environment that are existing on existing applications that you're building? And does it help you make more informed decisions about what you do and don't trust and allow inside your software security pipeline? And then other than that, is like the lab's still accessible. So, if there's anything I went over too quick earlier and you missed it, of course you can go back to it. And we've got, I believe Sam shared it in the chat. We have some other platform engineering resources there that'll go on over this topic in further detail.
We've also got the recording of this on YouTube. We're streaming there right now, and the recording will be there. So you're able to follow along a little bit slower if you would so like. But I wonder if there's a specific question anyone has now, or are you still digesting? Mm, digesting. This is usually the case with workshops. I find in webinars, people are like, okay, got my one question, but here, furiously absorbing along.
I think
Um,
the other side of it as well is like I'm always happy to answer on the platform engineering Slack. I think that's a great place to just ask every and any question if you want to ask privately. So I'm happy to take those questions offline as well.
Awesome. I think that's usually what happens. And since we're coming to a close now anyway, you've still got time. Going once, going twice. I know every single time this happens, I then get 10 emails right after with questions. So when you email me your question after this, no, I'm shaming you for not asking it. No, no shame. It's all right to be shy. And we'll make sure those questions get followed along. So thank you so much, everybody, for joining. And huge thank you, Nigel. I think this was super, super, super interesting. Nigel has a really great article up on our community blog as well. I think that Microsoft article that was shared is a really good read too. We actually link it within the article. And this Instruct workshop will still be up for a little bit longer. And I think I'm correct. So there's more you can play with here. And then you can just go on the Slack and check out Nigel and see all the stuff he's been up to. He's been doing lots of cool things. So, oh, one question from Lydia. How long would the lab be available?
Yeah, well, at the moment I haven't got a hard limit on it. So if I was to say 48 hours, I hope that's fair enough time for everyone to get a chance to play with it. And the idea is we're just constantly making changes to these labs to make sure the next time you join, I'll have newer, cooler stuff in it for future lessons. But yeah, probably 48 hours if that suits everyone.
Nice. And I'm sure if you send a really polite begging email to Nigel, he'll let you use it for a little bit longer. So
Exactly.
huge, huge thank you everyone so much for joining. I can see the thank you guys in the chat. That's always nice to see. And I look forward to your emailed questions after this, as I know they're coming. But no worries, guys. And thank you so much, Nigel. It was a pleasure as always. And I'll see you soon, wherever I see you. Everybody, have a great time wherever you are.